This is our interim report, analysis and redesign of bread slicers. We are Team 10, Alexis.
I'm Miguel.
I'm Chris.
I'm Richard.
So now into our product description. Bread slicers are used to slice loaves of bread into equal pieces. This device will allow users to place the bread in, turn the device on, and collect the slices. The sides are adjustable for different sizes of bread. There are two sets of knives that move up and down, while gravity brings the bread down. Also, the knives are either powered by a motor or by a hand crank, depending on what customer group they are from.
In our analysis, we studied two customer groups, the primary one being small to large bakeries, grocery stores, and markets, selling a variety of different breads on a daily basis. The slicer allows these groups to quickly slice bread to then be packaged and sold to their individual customers. We have target times for bread slicing from loading to unloading of about 5 loaves per minute and 1 single loaf in about 10 seconds. For the smaller variety of the bread slicer, we targeted a home or shared living setting where individuals who are either making their own bread at home or buy unsliced loaves are able to have professional quality bread slicing and have quicker and better quality meal prep. In order to analyze our high importance functional requirements of the bread slicer, we use a fast diagram in which we decided our task function was to slice bread, while our basic functions were to hold bread and make cuts. Within the hold bread function, we decided the bread slicer should contain the loaves as well as collect the slices post-slicing. Within the make cuts category, we figured the bread slicer should feed the loaf into the slicing mechanism and then split the bread, and then went a bit more specific into that category to say that the slices should be separated equally and the cuts should be even and straight. Further, we decided the bread slicer should be safe and prevent any injury to the user. And in addition, it should be an efficient method of slicing bread, which should increase the speed of the task.
Next, we have an exploded view of our bread slicer assembly. First, we start off with part 1, which is our pulley subassembly. This is comprised of a pulley, which then will be attached to some kind of an actuator, either a hand crank or a motor. The pulley is also attached to a lever, which then is attached to a secondary shaft, which then has an identical shaft on the other side, which then both of the shafts are connected to a primary shaft through the middle. Next is part number 2, which is our cutting subassembly. The cutting subassembly will later be attached to both of the secondary shafts. Next is our 2 side panels, part number 3. 4 is our back plate. 5 is our top ramp. 6 is our bottom ramp. 7 is our collection plate. And 8 is our top plate. Next is our assembly sequence. First, we start with the pulley subassembly, which has to start off in some kind of a vise or another kind of mechanism that will hold down the pulley subassembly while the rest of the parts are attached to it. As I said previously, next is our cutting subassembly, which is attached to the pulley subassembly's secondary shafts. They're attached by shaft collars. Next is our sides, which first have the bottom ramp supports attached to each side plate before then they're attached to the pulley subassembly by means of cutouts in the side plates. The back plate is attached next with the top ramp supports also attached, and then they're screwed down with the top ramp, then the back plate into the side. Next is our top ramp, which is then screwed down. Our bottom ramp is attached and also screwed into our bottom ramp support. Our collection plate is then added, and then our top plate is added to round out the assembly for the bread slicer.
We found multiple different variants online. This is the one that is closest to ours. There are some slight differences with a different side plate and top plate. We estimated that the wholesale cost would be about 60% of the retail cost. As this is for professional services, which are less price sensitive, we assumed a slightly greater profit margin. So estimate about 60%, a little less than the 70% suggested. For our product family design, we started with the pulley subassembly, which we would attach to a fixture. We then went with a cutting subassembly, side panels, and back plate, just as we did in the assembly diagram before. But instead of doing the top ramp next, we did the bottom ramp and the collection plate. We did this to enhance the delayed differentiation, as the top ramp for our secondary customers would be smaller than the top ramp for the professional services, as the individual families would maybe do only a single loaf compared to the multiple loaves that the professional services would do. The top plate comes next. This is the same for both variants, but due to the fastener requirements of the top ramp, it has to come later. We then add the actuator, which would be a motor for the professional services, as they'll be doing many different loaves and would just want to press of a button, and would be a hand crank for the individual families, as it would be cheaper and they wouldn't have to worry about electricity or finding a plug. And that should include our interim report.